I'm going to start with chapter 4, which is compound interest. So what is compound interest? Compound interest computation is based on the principle which changes from time to time. Interest that is earned is compounded or converted into principal and earns interest thereafter. Hence, the principal increases from time to time. The total amount grows by some fraction of the sum of the principal and the interest paid on all previous periods. Here are some of the common terms used in relation to compound interest: original principal, nominal interest rate, interest period, frequency of conversions, periodic interest rate, and number of interest periods in investment period. Here are the compound interest formula. Let's begin to answer all the questions. Part A, Question 1. Madam Rohaya wishes to invest her money in a fixed deposit account. She has two options, which is Bank A and Bank B. Bank A have the interest rate of 5.5% that are compounded quarterly. Meanwhile, Bank B have the interest rate of 5.2% compounded monthly. Question 1A. In which bank would you suggest Madam Rohaya invest her 10,000 ringgit for 3 years? Give your reason and show your workings. So first, we need to find the S, which is the future value of those two banks, which is Bank A and Bank B. The formula of future value is S equal to P bracket 1 plus I bracket the power of N. Based from the question, we know that P or the principal equals to 10,000 ringgit and I equals to K divided with M. So the K is 0.055 and the M is 4 because it is compounded quarterly. In order to get the power of N, 4 should be times with 3. So it should be S equal to 10,000 bracket 1 plus 0.055 divide 4 bracket the power of 4 times 3. We need to solve the numbers in the bracket first and the power of N. So the answer will be S equal to 10,000 bracket 1.01375 bracket the power of 12. After that, the numbers in the bracket should be solved including the power of 12. So, the answer will be S equal to 10,000 bracket 1.178068128 bracket. We need to times the answer in the brackets with 10,000. So, the final answer will be S equal to 11,780 ringgit and 68 cents. For Bank B, we need to use the same formula to find the future value of S. So the formula should be S equal to P bracket 1 plus I bracket the power of N. Based on the question, the principal is still the same, which is 10,000 ringgit. And the I equals to K divides with M should be 0.052 divides with 12. It is because for Bank B, the interest rate is 5.2% and compounded monthly. And the power of N should be 12 times 3. So it should be S equal to 10,000 bracket 1 plus 0.052 divides 12 bracket the power of 12 times 3. So as usual, we need to solve the numbers in the bracket and the power of N first. And it should be S equal to 10,000 bracket 1.004333333 bracket the power of 36. And then we need to solve the numbers in the bracket first, and it should be S equal to 10,000 bracket 1.168432344 bracket. So in order to get the final answer, we need to times the numbers in the bracket with 10,000, and the final answer will be 11,684 ringgit 32 cents. So, to answer the question, Madam Rohaya should invest in Bank A because Bank A provides a better deal and a handsome future value than Bank B at 11,780 ringgit and 68 cents.
Let's continue for question 1B. Question 1B given if Madam Rohaya invests 13,000 in Bank A for 5 years and 6 months, what is the amount of interest obtained when the investment periods end? For this question, we will use the formula of future value. The formula is S equal to P open brackets 1 plus I, which is I is K over M, and then we will close the brackets and the power of n. Small n means by n equal to m multiplied by t. We will insert the amount into the formula, which is S equal to 30,000 open brackets 1 plus I, which is K over M 0.055 over 4. Close the brackets and we will insert n, the power of n, for open brackets 11 over 2 close bracket. After we calculate the amount, we will get 30,000 open the brackets 1.01375 close the bracket 22. After we calculate again, we will get 13,000 open the bracket 1.3504 51771, and we will close the bracket. For us, we will get 70,555.87 cents ringgit Malaysian. For this question, it's asked for what is the amount of interest obtained when the investment period ends. For find proceed, we will use the formula I equal to S minus P, which is we will insert the amount 70,555.87 cents ringgit Malaysia minus 30,000 ringgit Malaysia. So we will get 4,555.87 cents ringgit Malaysia. For question 1C, is given Madam Rahaya want to have 28,000 in 4.5 years. She is interested in investing in Bank B. How much should she start with? For this question, we will use the same formula as 1B. For this, we have to find the amount that how much she should start with. So we will insert the amount into the formula, which is S is 28,000 equal to P, open the bracket, 1 plus I, which is K over M, 0.052 over 12. And then we will close the brackets, the power of n, which is 4, open brackets, 9 over 2, and close the bracket. We will calculate in the bracket first, and then we will insert the calculator. Then we will get 28,000 equal to P, open bracket, 1.0043333 and 3. Close the bracket, the power of 18. After that, we will insert into the calculator again, and we will get 28,000 equal to P, open bracket, 1.080940484, close the bracket. After that, 28,000 have to divide with 1.080940484. Then we will get 25,903 ringgit and 37 cents.
Question 1D. Madam Rohaya wished to invest 28,000 ringgit Malaysia in Bank A. Her target is to accumulate 60,500 ringgit Malaysia by the end of the maturity period. How long should she wait to reach the amount? For this question, we are going to use the formula which is S equal P open bracket 1 plus I close bracket the power of N. By this formula, we just enter the amount from the question given. 60,500 equal 28,000 open bracket 1 plus 0.055 over 4 close bracket the power of N. After that, 60,500 equal 28,000 open bracket 1 plus 0.01375 close bracket the power of N. And then the number inside the bracket must be moved into the left side, which is 1.01375 the power of N equal 60,500 over 28,000. To calculate, we need to enter log, which is small n log 1.01375 equal log open bracket 60,500 over 20,000 close bracket. After we calculate, we will get small n open bracket 0.00593086719 close bracket equal 0.3345973,433. So after we calculate, the small n is 5641. After we round up, we will get 57. N equal 40. 40 equal 57. So for the small t is 40.25 years. The final answer was 40 years 3 months. What is annuity? An annuity is a financial concept where equal payments are made at regular intervals over a period of time. These payments occur at the end of each payment period. There are two types of annuities to consider. First, future value annuity S. This is the total value of all payments made by the end of the term. It includes both the periodic payments and the interest that accumulates over time. For the second, present value annuity A. This represents the current value of all future payments calculated at the beginning of the annuity term. Annuities are commonly used for saving plans, retirement funds, or loans, making them a valuable tool for financial planning. There's a formula of annuity. An annuity refers to a series of equal payments made at regular intervals over a specific period. This concept is widely used in financial mathematics for loans, investment, and saving plans. Number 1. Future value S. The future value of an annuity S represents the total value accumulated at the end of all payments including interest. So for the formula is S equal R open bracket 1 plus I close bracket the power of n minus 1 over I close bracket. For the second formula, which is present value A, the present value A refers to the amount needed today to generate the specific payments over time considering the interest rates. So the formula is A equal R open bracket 1 minus open bracket 1 plus I close bracket the power of negative n over I close bracket, whereas R is the periodic payment of the annuity. Small n is the total number of payments. I is the interest rate per payment. As future value of annuity, last but not least, A is present value of annuity.
Part B, Question 1. XX Bank offers a personal loan of 30,000 ringgit with an interest rate of 4.5% compounded monthly. The customer has to pay back the loan through monthly payments for 5 years. Question 1. A. Find the monthly payment. For this question, the formula that we will use is present value of ordinary annuity. The formula is A equal to R open bracket 1 minus in bracket 1 plus I, which is K over M, with the power of negative N over I. So here we have 30,000 equals R open bracket 1 minus open bracket 1 plus 0.045 over 12 close bracket the power of negative 60 divided by 0.045 over 12 close bracket. First of all, we need to do the calculation for the mathematical problems in the bracket. Open bracket 213.027283 close bracket. Then we will get 30,000 equal to R, and then we will get R equal to 30,000 over 213.027283. So we will get the amount of the monthly payment, which is 140 ringgit 83 cent. Question 1B. Immediately after paying the 14th payment, the customer decided to settle the balance of the loan. Find the amount to be paid. We will use the same formula from before. So A equal to R open bracket 1 minus open bracket 1 plus I close bracket the power of negative n over I close bracket. I equal to 0.045 over 12 and negative n is negative 12. Then A equal to 140 ringgit 83 cents open bracket 1 minus open bracket 1 plus 0.045 close bracket the power of negative 12 over 0.05 over 12 close bracket. Then 140 ringgit 83 cent open bracket 0.04392205385 over 0.00375 close bracket. Then we will get 140 ringgit 83 cent open bracket 11.71254762 close bracket. From there, we will get RM 1,649 ringgit 48 cent.
Part B, Question 2. Danish took a personal loan of 15,000 ringgit and paid equal monthly payments for 6 years at an interest rate of 4.4% compounded monthly. Question 2A. Find the monthly payment and the total interest charge. First, the information that we could get from the question is 15,000 ringgit is A, which is our present value. Next, the equal monthly payments, which is R. After that, our small t is 6 years. Next, our K is 4.4%. Next, we have to find the negative n. Negative n equal to 12 times 6, which is equal to negative 72. The formula that we are going to use is present value, which is A equal to R bracket 1 minus bracket 1 plus I bracket the power of negative n divided with I bracket. After that, we should include all the informations into the formula, which is 15,000 equal to R open bracket 1 minus bracket 1 plus 0.044 divide 12 bracket the power of negative 72 divide 0.044 divide 12 and close bracket. In order to get the final answer, we have to complete the bracket 1 plus 0.044 divide 12 bracket and multiply it with the power of negative 72 and 1 minus answer. After that, we will get the answer R bracket 0.23165555777 divide 3.66666667 times 0 the power of negative 3 bracket. Next, we will include the 15,000 equal to R bracket 63.1787992 bracket. Next, we'll move the 15,000 to the back, which is R equal to 15,000 divide 63.1787992. So, the final answer for the monthly payment is RM237.42. After that, we should find the total interest. The formula for total interest is I equal to N R minus A. Then we have to include all the information, which is I equal to 237.42 times 72 minus 15,000. Then 17,094 ringgit and 42 cent minus 15,000. And the final answer for the total interest charge is 2,094 ringgit and 42 cent. Question 2b. If Danish failed to pay the first 4 monthly payments, find the amount he had to pay on the 5th payment to settle the outstanding arrears. And for this question, we are going to use the formula of future value, which is S equal to R, open bracket, bracket 1 plus I, bracket the power of n, minus 1 divided with I, close bracket. Then it will be 237.42 cent, open bracket, bracket 1 plus 0.044 divide 12, bracket the power of 5, minus 1 divided 0.044 divide 12, close bracket. Next, we have to solve the numbers in bracket first, which is 1 plus 0.044 divide 12, bracket the power of 5, minus 1. And then it will be 237.42 cent, bracket 0.01846827165 divide 3.66666667 times 0 the power of negative 3 bracket. Next, we'll get 237.42 cent, bracket 5.036801367 bracket. And the final answer for the payment Danish had to pay for the 5th payment is RM 1,195 ringgit and 84 cent.